Okay, so we've talked about the control source list, and we've talked about the automated controls, the LFOs, the ASRs, and the envelopes. And now we've even talked about envelope control. And we're left with one last fancy module inside the vast layer structure, and this is called the fun. A fun is where you can process control sources. So imagine we have a wheel assigned to the parametric equalizer, just like we have. That mod wheel is a control source, but I could process that control source. Maybe I want to add the mod wheel and whatever the attack velocity is, for example, and I will use a function to do that. So I've gone to the fun page, and I've said that the function 1, I have 4 functions that I can use, and they can be assigned anywhere in the layer, multiple times, just like any of the other control sources. So I've set up a fun here. Let's say the input A is the mod wheel, and the input B is, let's say, attack velocity. And the function is very simple, A plus B. Now, if I go back to my algorithm, and we see I have the parametric equalizer. This is the example from a couple of sessions ago. And I hit that edit button, and I can see my frequency is G4, and I hit the modulator, the modulation page, and I see that the mod wheel controls that frequency cutoff. Instead of the mod wheel, why don't I assign this function that I just set up? It's after the LFOs and after the ASR. There it is, fun1. So now fun1 is assigned to affect this EQ frequency. And if I hit edit while it's highlighted, I can jump to its page. Of course, I can always find the fun page on the soft buttons as well. The fun page. Now mod wheel plus attack velocity are controlling. So now not only can I hit softly and raise the frequency with my mod wheel, or I can hit hard and it'll be raised right then. So now I have 2 control sources been combined into one. I can also say A minus B. Well, that's the second function, and you can gather what that might be. That means mod wheel is affecting it, but minus how much attack velocity. So if the attack velocity is low, mod wheel affects it quite a bit. But if attack velocity is high, it's not going to affect it as much. Let's see. We have, and then I'm not going to go through musical examples for every single one of these, but you can start to see that the functions can be very specifically organized. You can say it's both of them, but it's going to be by half. So now neither of them is going to take me to max by itself, but if they're both maximum, it's going to be the maximum effect. So if I have a nice high velocity and the wheel's up, then I get my max depth, but if not, not. Some of the most useful functions that are used often is the low pass function, and this is actually the same mathematics that occurs at the sample level in the time domain inside the chip when you've assigned a low pass filter. It rounds off a sharp control source, making it duller. And if you can imagine the mod wheel, I'm going to say that to assign the low pass is to the mod wheel is going to be to add a low pass filter on the control. The mod wheel as a control source, not as a sound, but as a control source. So I'm going to say my input B is the mod wheel, and the input A is actually going to be the frequency cutoff of this low pass fun. And you'll notice the control source list is slightly different for the fun page because we want to be able to add specific amounts. So there's a whole set of constant values added at the beginning of the control source list when you're on the fun page. And I'm going to set something really low. And watch what it does. Now I have the mod wheel is affecting the cutoff frequency of this parametric equalizer, but watch me move this wheel all the way up really fast. But watch how long it took, or listen to how long it took for the control source to really catch up. That's because I've applied a low-pass filter to it. Now, this is one of the many, many ways in which programming the PC3X or any Kurzweil instrument teaches you about sound and teaches you about sound processing. because when you think about a sawtooth waveform and when you apply a low-pass filter to it, it rounds it off. It can't actually jump from one value to a very different value very quick. It has to actually ramp up to the new value. And this is the kind of mathematics that's going on here. One of the best uses of the low-pass fun is when you're using monopressure, because let me just say that let me just turn the constant all the way to on. Input A is on, and I'm using a low, so it's like opening up the frequency of this low-pass filter, and I'm really just listening now to monopressure as it affects this frequency cutoff here. I'm pressing in like that. It's very hard to control. It's a drastic effect, but I just want to press a little bit, and I don't want so much. If I add this, it's also called a lag function in many other synthesizers, and I think it's the low-pass fun. So if I now apply to the pressure this low-pass fun, I seem to have much more control when I press, because as it starts to happen, I can do it nice and slowly. So you will find, actually, if you examine many of the sounds in this instrument, you will find that these funs have been applied all the time. It's one of the things that can make a program hard to decipher at first, but it's one of the things that makes these sounds so realistic and very controllable. So I have a lot of control over pressure because I use this low-pass fun. I can even find it here. But here it is. We look. This is what is swelling here in this sound. I have woodwinds here, and they have an automatic swell and an automatic based on envelopes. So that part is automatic, but then the swell is on the strings. And we can see that low-pass fun. If you look at the string layer, and we can see that the level of this is assigned to the fun with a 6 dB boost, and that fun is the low-pass. And the control source is mod wheel plus monopressure, which is a special additions to the beginning of the control source list that allow us to combine some commonly used combinations. So if you use pressure plus mod wheel, as we do in most of the orchestral and string bank, you can choose whether you want to do your swell with the mod wheel or with pressure. And in both cases, it's applied by this low pass, so it's nice and smooth and musical and easy to use. So that should about do it. We started out, we examined the key map page, we realized that we can assign these preset ROM multi-samples here, and that we can control their transpositions. And we saw that we have many ways to control the layers and how, as to when they're enabled and how they start, and assigning a delay. We've experimented with pitch control, and we've seen that inside the algorithm you can have many different DSP functions, each of which has its own set of controls that you can assign to it. And then we talked about the depth controls, and the first control source that has just a maximum depth, and the second control source that has a separate depth control, and how those apply to any of the DSP functions inside the algorithm. And we have also looked in detail at that control source list that appears as the value list for so many of the parameters throughout the machine, whether it's the pitch of the sawtooth wave, or whether it's the rate of the LFO itself, or whether it's the amount of delay that's going to be applied. This control source list is available everywhere. And hopefully now you have an idea of how those various control sources are used and how to program the specialized ones, which are the LFOs, the ASRs, and the envelopes.